Good day, everybody. This episode is in Blue Metal Technology, SMS Group efficient technology for e-scrap recycling. E-scrap today is a very interesting and valuable source for precious metals as well as valuable metals such as copper, lead and tin. Worldwide, over 45 million tons of e-waste are generated annually, with a tendency to dramatically increase over the next years. A problem with this e-waste is still the collection rate. Only 20% of the totally generated e-waste are annually documented and collected and recycled properly. Still, 80% are not documented, not properly recycled due to a lack of legislation or lack of knowledge or technology. When we're talking about e-waste, we are focusing on 3,000 different waste types which we identified as a potential input source for our refining our recycling process. That's why we have conducted a market survey to identify where or which locations on the world these scraps are accumulated and currently collected, so that a smelting or refining or recycling process is economically feasible. As you can see here in the table, these are three regions with America, Asia and Europe, where you can see that Europe is the leader in terms of collection rate. This is probably because the legislations are here the strictest and the most developed. But over the next years, America and Asia will develop that as well. The legislation will get stricter and the collection rate will increase. That means that more raw material is available on the market. So that, in a summary, shows us that there are very good market opportunities in these areas with a lot of scrap which is accumulated and collected. When we're talking about e-waste, or WEEE, which is a short form for waste of electrical and electronic equipment, we are not talking about the entire e-waste. We're not talking about refrigerators or microwaves as a total product. No, we are talking rather about a concentrate. This concentrate is a mix of different categories which are exemplarily given here. So we are talking about PCBs, so-called printed circuit boards, copper meatballs, CPUs, RAMs, cables and connectors, mobile phones or shredder light fractions. All of these categories have metal content in it, but also a very high organic fraction. These special feed mix is completely different for each client and is each time completely different, so that every raw material mix probably needs a different approach. The only thing what is similar with all processes or all raw material mixes, that is the final products. The final products are usually pure gold, silver, copper, platinum, palladium, as well as lead and tin, which comes in the solder, and nickel. How do we treat the scrap? We develop a Blue Smelter, which is a very intelligent smelting solution. This smelter takes the scrap and combusts the organics which are coming within the scrap, and transforms the organics which are coming with the scrap into heat. That means that the process, the smelting process, which smelts the mineral components and the metals, which are separated in a metal phase and a slag phase, completely autothermal. That means we do not need any additional fuel or energy to run the process. Once started, the process fuels itself. Subsequently, following to the smelting process, we have a very complex off-gas treating system to ensure that we meet the environmental requirements. We have tested the smelter in a quite big scale, in demonstration plant scale. That means we built the smelter for 3,000 tons per annum and tested it on its half. We tested very high organic loads, we tested a mix, we tested very low organic loads, and they're very impressed by the results. The results exceeded our expectations. That means the vessel was so flexible and so good controllable that we achieved higher metal recovery rates as expected. That means your losses to the slag are at a minimum. So how do the process look like? Starting from Blue Smelter, where we add the scrap and produce a black copper, as mentioned before, that means we transfer we collect all the metals which are coming within the scrap into a liquid phase. This can be then transferred to a further process or sold to the market as a solid black copper product. If you decide to further process it, you will transfer the material to a TBRC or ladle stand. In this TBRC or ladle stand, you oxidize the material and produce a lead tin alloy or slag and transfer then the raw copper into further processing steps. In option A, we're focusing on optimizing this raw copper. That means we generate a very fine powder which is usable for a leaching process. In this leaching process, copper and nickel are going into solution and are further transferred to an electrowinning process where we generate products as copper cathodes and a nickel product. In this leaching process, the more noble metals like gold, silver are not going into solution and are collected in a sludge. This sludge is then transferred into the precious metals plant where we separate all these metals from each other and transfer it into high-grade products. This route is the quickest route for recovery of precious metals, but you have to take an increased OPEX due to the leaching process where you have to add oxygen and an energy-intensive electrowinning process in comparison to conventional electro-refining processes, because electrowinning has a bigger or an increased consumption of energy. Option B is the other way, so that we do not leach it and do not need a powder, so that means we granule the raw copper by a granulation step or casting and cutting. These granules are then transferred into baskets which are hanging in an electrolyte so that a conventional electrolysis can be conducted. As products we got cathodes, copper cathodes and a nickel product. After a while the precious metals which are not diluted in the electrolyte or resulting in the copper cathodes or nickel product are collected as a sludge and transferred into the precious metals plant where then are separated into high-grade products. This process route is the simplest process route because we have no leaching, we have a direct casting process, we have low OPEX with a quite comparatively quick precious metals recovery, but the recovery is not as fast as compared to the electrolysis, the option A. When we're talking about A and B, we see that the generated raw copper has no dilution. That means there is no additional copper added. When you compare it to option C, where we are processing or where we intend to produce anodes for a conventional electrolysis process, we have to add copper. This is because we need a certain amount to effectively or efficiently run the anode casting wheel or the anode caster. This generates a higher input source, or it requires a higher input source of pure copper scraps. That means we have an additional furnace in that process route. Here in that case we're using a laboratory furnace where we add copper scraps of greater than 90%. That means this process route is not intended to only recycle e-waste, it's also an option for copper production or copper recycling. That means it's in comparison to both or the other two process routes more flexible in terms of input materials, but we are diluting our precious metals because we have to add more copper scraps. Summarizing, we have a very flexible smelting unit with a Blue Smelter. Currently it's intended to treat 3,000 to 10,000 tons per annum of e-scraps, but is certainly upgradable to up to 100,000 tons per annum. We have a very modular design and we have a very flexible design. As we have seen, we can adjust and put together, assemble all these technology steps as intended to, so that we have for each raw material the most effective and efficient process route. Another thing what I want to highlight here is that with the Blue Smelter, it is maybe very convenient not to sample each batch individually. So that means if you're getting smaller, high-grade batches, you can run this batch and sample the material after smelting. That means you run it batch-wise, separate the metals from the slag phase, analyze slag and metal, and get a very precise analysis. Another thing I want to highlight here is an expansion of the Blue Metal plant. It's the so-called high bay storage. This is the intelligent storage solution where you can store each individual scrap, let's say scrap quality, which you purchase in an individual lot. So we have the possibility to store more than 2,000 different lots of WEEE, which is then individually sampled, and then because this entire system can be digitalized, you have the possibility to address each scrap individually and assemble it and mix it up so that you have the most, let's say, homogeneous running plant, or you even can adjust it so that you get the best values and the best valuable scraps mixed up so that you produce a very, very high values charge. Another thing is the dry slag or power slag process. This is an improved process for granulating the slag without addition of water. That means we are generating from the slag a very good sellable product for the market, which is good usable as a blasting material, so that you don't have an, let's say, product for dumping, so it's a product for a market. This process can also upgrade it with the power slag process, where we add a boiler system so that we can extract the heat out of the slag and recover the energy so that we can, let's say, increase the entire energy balance of the plant. Summing it up, we are focusing on the fast-growing WEEE market with great opportunities. Therefore, we offer tailor-made solutions for each individual scrap, from pre-treatment over the smelting and refining up to final high-grade products, with a very efficient recovery of these valuable metals. Because of this flexibility, we are in the position to really have very interesting business cases with highly profitable solutions. But we are not only focusing on the metals, we are also focusing on environmental impacts. As we have seen, we have several solutions to upgrade the environmental impact so that you have a safe and clean working environment, and you can also reduce your footprint by recycling the materials, the internal materials, and extracting the energy which is coming within the process and put it back into your process. Thank you very much for your attention.